Welcome. Continuation to the previous lectures. In this lecture also, we are going to continue with the examples in R2. The first example that we are going to see is the segment A comma B is to be considered as a subset of R2, which means we can choose a segment in either of the axis and only the points on the axis we are going to consider. Okay. In order to check whether this is closed or not, what should be the case? We'll have to see the limit points of this and whether we have to check those limit points are members of the set or not. Okay. I can choose whatever may be the point and a minimal radius, and I can see that there are some points other than this which is a member of a set is present in the neighborhood. Therefore, all those points inside this will be the limit points. Even if I take this point, that is a comma 0, that is also being a limit point of this set. But a very small radius you choose, and you can see some other points of the set is present in the neighborhood, but this point is not a member of a set. Similarly, this b comma 0 is also a limit point of the set, but this is not a member of a set. Therefore, the segment a comma b is not closed. Okay, let us see whether this is open or not. Whatever may be the point that you choose, you will have a neighborhood of this sort. Big radius or small radius, but it is going to be some circle, but the circle has many other points which is not a member of this segment. Therefore, this is not open as well. When this is not closed, you can come to the conclusion that this is not perfect too. And it is left to check whether this is bounded or not. Yes, it is bounded, because as in the previous cases, you can find out the distance of these two things and find the maximum of this distance to be m, and this set is bounded by this value m. This is going to, even if it is a bigger value, this is going to be some finite value. So this is bounded. Next example that we are going to consider is the entire R2. Or we can consider this to be the set of all complex numbers too. All the points on this plane are to be considered in this case. Okay, now we will see whether this is closed or not. Okay, before checking whether this is closed or not, let us try to identify the limit points of this entire R2. Repeated application of the definition of a limit point tells you that all the points on this plane are being the limit points to this plane. Okay, whether you choose a smaller radius or bigger radius, in all possible radius you can find out that the neighborhood is containing many other points of this R2. Therefore, your R2 is closed. Okay, whatever may be the point and you choose any radius, okay, this neighborhood is completely contained in your R2. Therefore, your R2 is open as well. Okay, then perfectness. In order to say this is perfect, it has to be both closed and all the points of this set is a limit point. Here is the case. So your R2 is perfect. Whether this is bounded or not, it is obvious that it is containing infinite number of points and we cannot bound it because it is going till infinity. Okay, so your R2 is not bounded. Here in this case, this AB, here A and B are some known values, that is either of them is not infinity, neither of them are infinity. Okay, so these are all the things. In these two examples, you might have noticed one more thing, that is this first set is an example of neither closed nor open, and the second is an example of both closed and open. So based on the set and based on the metric, the openness and the closeness may vary. When you consider this, that is your segment A comma B as a subset of R, okay, only a subset of R with the metric that standard Euclidean metric, this is open. Okay, here also it is not closed, it is not perfect and bounded. So this one you may have as an example of a set which is open in R but not open in R2. Okay, thank you for watching this lecture. If you have any doubts, you can post it in the comment section. Thank you.